105 qubits. Every possible answer held at once inside one supercooled chip. No magic, no shortcuts. Then you measure, and all that possibility collapses to a single result. Here's exactly how it works. Quantum computing gets sold as pure magic. The truth is stranger and far more limited. These machines don't try every answer faster. They use one weird rule of physics to lean toward the right one. Understand that rule, and you understand both what they can do and what they can't, including the encryption everyone's suddenly worried about. Start with an ordinary computer bit. It's strictly one thing, a 0 or a 1, like a switch that's off or on. A qubit breaks that rule. It can sit in a blend of both at once. Physicists call it superposition, both spin up and spin down at the same time. But here's the catch. The blend only lasts until you look. The instant you measure a qubit, it stops hedging and snaps to one definite value, 0 or 1. That's the whole trick behind the headline. 105 qubits can hold every answer at once. Every combination all superposed right up to the moment of measurement. Then they collapse to just one. Now link two qubits together. When qubits are entangled, they stop being separate. Measure one and you instantly know the matching state of the other, even if it's across the room. Einstein hated this. He called it spooky action at a distance because it looked like the two were secretly talking. So does that mean information jumps faster than light? No. That's the misconception almost everyone carries. You can't use entanglement to send a message faster than light. Each measurement on its own looks completely random. The correlation only shows up later when you compare notes the ordinary way. Entanglement links the qubits' results. It doesn't beam data across the gap. Here's where reality bites. Qubits are fragile and error-prone. A stray vibration, a flicker of heat, and the answer scrambles. So the real barrier isn't raw qubit count. It's reliability. For years, adding qubits added errors and everything fell apart. Google's Willow chip changed that story. With 105 qubits arranged to check each other, it drove error rates down as more qubits were added. It crossed a milestone called below threshold that the field chased for decades. IBM is pushing on scale too. Its Nighthawk processor links 120 qubits with 218 tunable couplers, the wiring that lets qubits talk. And IBM says it's aiming for a large fault-tolerant machine, one that fixes its own errors by 2029. So what are these machines actually good for? A leading researcher lists 3 real uses: simulating quantum physics and chemistry, breaking some of today's encryption, and eventually modest gains in optimization and machine learning. That's it. No universal speed up for everything. The encryption piece is the one that spooks people. A 2025 Google paper estimates a future machine could crack a 2048-bit RSA key, the math guarding much of the internet, in under a week, using fewer than 1 million noisy qubits. That's a huge drop from a 20 million estimate back in 2019. But read the fine print. No quantum computer alive today can do this. Vendor roadmaps only reach hundreds of thousands to millions of qubits in the early 2030s. Here's the part that resolves the fear. The threat is future. The defenses are already shipping now. NIST, the US standards body, finalized post-quantum cryptography in 2024. 3 algorithms, MLKEM, MLDSA, and SLHDSA, built to resist a quantum attacker. And the rollout has started. Apple rebuilt iMessage's encryption with a post-quantum design called PQ3. Google's Chrome switched its key exchange, the handshake that secures HTTPS, to MLKEM for billions of connections. So strip away the hype and 105 qubits aren't a doomsday. They're a milestone. The whole machine underneath is just 3 ideas stacked together: superposition, entanglement, and error correction. So that's the box opened. A qubit holds every answer at once, until measurement collapses it to a single one. No spell, just physics with sharp limits. Stick around. We open the next black box behind the headlines you keep hearing about.